All right, so I'm gonna pick back up where I left off on the last one. So let's draw that cloud. And we're wanting the height, so I'll just go ahead and draw that. I'm not directly under the cloud, I'm some distance away, and I'm pointing something that measures the angle. All right, so you label the parts that you know. All right, so we want the height of the cloud, so I'm going to call that h. You can call it whatever we want to. And the trig ratio that relates these sides to that angle is going to be the tangent. So the tangent of 64 degrees, 40 minutes is equal to the opposite over the adjacent. If the variable is up high, you're going to multiply. And then to type that in, we should get this cloud is 295.73 feet. All right, on 16. While standing on a cliff 163 feet above the ocean, I see a sailboat in the distance at an angle of depression of 21.2 degrees. What is the horizontal distance to the sailboat? Okay, so here's the cliff. Up here I am. Okay, so then we have some water, and then there's a sailboat. Okay, so I'm looking down at you. We're looking down at the boat. All right, so I know how tall the cliff is. And I know the angle of depression. Now the angle of depression is formed with the horizontal, not the vertical. So this angle is 21.2 degrees. Now, I'm not going to draw another triangle because I know that if you're down here in the boat looking up at me, your angle of elevation would be the same as my angle of depression. So I just go ahead and instead of labeling the angle of depression and draw a new triangle, you can just label the angle of elevation. And what I want to know is the horizontal distance to the sailboat. So from the cliff to the boat, we'll call that D. All right, so looking at those, looks like we're going to use tangent. So the tangent of 21.2 degrees is equal to the opposite over the adjacent. And the variable is down low. We're going to switch. All right, and then in the calculator, that should be 420.24 feet. Okay, so then we have another wire question. This one is a little different. So a wire holding up a 40-foot telephone pole is 38 feet long. The wire attaches to the telephone pole 10.5 feet below the top. And then we want the angle of elevation of the wire. So this one, we have our pole, but kind of top middle is where the wire comes down. All right, so you guys try to label all the things you know. All right, so if the whole telephone pole is 40 feet, and then this part at the top is 10.5 feet, that's the part we don't want, so we just subtract. And we get the part of the triangle that we want is 29.5 feet. All right, what we want to answer the question is the angle of elevation. So we find the horizontal and label the angle there, theta. That's what we want. Okay, and then this stuff we don't really need. So then looking at what we have and what we want, we are going to use sine. So the sine of theta is equal to the opposite over the hypotenuse. And then don't forget, if you know what the sine is and you want to find the angle that has that sine, that's when you do the inverse sine or the arc sine of 29.5 divided by 38. Okay, so in the calculator, it's second sine. And as long as you're in degrees, it'll give you the answer in degrees. And that's what we would want. So that should be approximately 50.92 degrees. That's the angle of elevation of your wire. Okay, last one for today is number 18, and this one is kind of tough. Normally, I kind of divide up the class to do this one together, but that'll be a little difficult for me to do from home. So from a window in building A, I observed the top of building B across the 50-foot wide street at an angle of elevation of 74 degrees, 25 minutes. I observed the base of bottom B at an angle of depression of 52 degrees, 18 minutes. We're going to find the height of building B. All right, so I'm in A, and I'll put my window right here. Right, B could be shorter or taller than A. It doesn't really matter. I'm just going to draw that a little taller. Okay, so I do know that in between the buildings is 50 feet. And I am looking up at the top of building B. I do need to draw a horizontal line. So anytime you're using an angle of elevation depression, there has to be a horizontal line. And so that's going to be 74 degrees, 25 minutes. All right, I'm also looking down the base of building B, and that angle of depression with the horizontal is 52 degrees, 18 minutes. So what I can do is find this height and this height using trigonometry, and then just add them together to find the height of building B. All right, and then this horizontal right here is 50 feet. We could redo it. Oh, that's a lot of stuff right there. So to find x, I'm going to use the tangent. So the tangent of the angle is equal to the opposite over the adjacent. The variables up high are going to multiply. All right, you guys try y on your own. Okay, so you should get 64.69 feet. So then if I want to find building B, I'm just going to add those two together. And that's going to give me approximately 243.97 feet. So who knows? You might be bored one day in a big city and have some measuring tool and your graphing calculator with you, and you might want to figure that out. All right, what I want you guys to do for your assignment today is on pages 10 through 11, do numbers 4 through 11.